is the cost of production. But on these challenges, the industrialization of our nation also contributed in polluting our environment. To overcome these challenges, the researchers have tried to find a replacement for the fossil fuel, making use of ourselves. The major advantage includes the non-toxicity, high thermal and chemical stability, which cause periodic charge carrier properties and availability of this material. Then we have some challenges which include the wide band gap of this material, which only enable you to fully absorb in the UV region. Then the high rate of electron holes in convention rates. To overcome these challenges, we hope these materials try to modify its chemical properties for it to be able to counter some of these challenges. Our aim in this research is to improve the photovoltaic and photocatalytic activities of TIO2 by doping and co-doping with some matter and non-metal using hydrothermal method. Co-dope and affect TIO2 and other with carefully selected metal and non-metal using hydrothermal method. Characterize these doped and pristine samples for their optical, morphological, and structural assessment. Then we determine the improvement of in the performance of this fabricated solar cell using all the group components. Then finally, we then determine the use of direct. So many work has been carried out in trying to improve the efficiency of solar cells and also use the TIO2 in our environment. But most of these researchers have never considered the effect of the chemical material that we are going to use at least. Then the methods. The 16 grams of sodium hydroxide pellets was mixed with 80 ml of distilled water. Then after mixing it, we then use it as a solvent. Then we use this measure one weighted percentage ratio of each precursor and mix it with this solvent. And after mixing, we then put it in autoclave 50 degrees centigrade and subject it to hydrothermal treatment for 24 hours. Then after that, we then was measured and then mixed with 14 different characterization XRG, which we use, and FTIR, the same 10. The XRG results, which was presented in figure 4.1, we then discover from our XRG result that the two major peaks of this is the plane 101 and the 200. Then we discovered again the another peak at 110. We try to calculate the entire phase making of equation 1. After our calculation, we discovered that this material has 80% anatase phase and 20% butyl phase. A more diameter than the titanium ion. Then we also discovered the broadness of the weight and half maximum. The broadness of just weight and half maximum also supported our claim that this material is a polycrystalline material. Then we discovered that the crystalline size actually decreases, which also was the reason for the increase in the microstrength and its location density. The calculated crystalline size was calculated our crystalline size making use of equation 3, and the microstrength making use of equation 4, and its location density making use of equation 5. Then the cell analysis. In our cell analysis, we then now see that the material itself is slightly agglomerated spherical-like nanoparticles. This material, the slightly agglomerated And each of all these particles we are found in the we are able to find all these pollutants in their small percentage ratio. Then the tenth analysis. In our tenth analysis, then we also observe, after calculating our particle size, to see that there was a decrease in particle size, which also supported what we have in the SEM analysis with iron slash copper. Then we also observe, after looking with iron slash copper slash nitrogen, that the particle size actually increases a bit with which also corresponds with what we observe in the SEM analysis. Then, in the same way, doping with iron, which actually show more agglomeration, as observed both in SEM, and calculated particle size also increased, which also supported our observation in SEM and SEM analysis. Then, the same image, the insert, the same image, which is insert image in that diagram, which we have a concentric circle, supported the idea which we have from our XRD results that this material is a polycrystalline material. We're trying to calculate the displacing, making use of this set image, and our calculated displacing for plane 101 compared with that of that which we calculated from the XRD. There was a similarity. You can see that all of them are closer. From the iron slash copper doped TIO2, there was calculated displacing. Here is 3.5. From the set image, our calculated displacing is 3.6. The same thing happened with that of iron slash copper slash nitrogen slash same dot, and the same thing is applicable to then the FTIR. In our FTIR analysis with a solvent, we also observed that there were some other functional group that was dictated. Then the next plot. Iron, copper, nitrogen, cerium. Then doping TIO2 with cerium from our discovery actually give us the highest efficiency. Then followed by doping with iron, copper, nitrogen, and cerium. Then doping with iron itself alone actually reduces the efficiency by the VOC and the current density itself. Then, by adding copper to that, actually improve that VOC and the current density itself. Then, also doping with copper, nitrogen, iron, copper, like nitrogen. Then going back to reduce this efficiency backward. Then to calculate our efficiencies, we make use of equation 7, and to calculate the power, the maximum power, we make use of equation 8, and the fuel factor, we make use of equation 9. Then these are the table of our results. From our table, we see that there was an increase in the efficiency to 0.718%, making use of cerium TIO2. And the least efficiency was making use of iron dot with an efficiency of 0.025. Then again, followed there was also an improvement doping with iron, copper, cerium, nitrogen. And the dose samples are closer, which actually suggested that doping does not alter the crystalline material itself. Then we then observe that each of the peak is the wide band gap of the wide listing of the peak, that the peak is so broad. The broadness of this peak actually suggested that this material is a polycrystalline material. Then, from our results from the XRD, the result of the XRD used in the crystal side, doping with the iron copper TIO2. Doping with iron alone